but we're going to do it. So here we go. We're going to find the decimal for negative 7/8. All right, who remembers, and this is supposed to be easy, okay? I know it's easy. These are the prerequisites. It's supposed to be easy. Who remembers how to change a fraction into a decimal? I think I heard somebody say divide.
Divide.
Yeah, that's what you do, you divide. And when we divide, and yes, we're doing all good old-fashioned long division. When we divide, the number on the top goes inside, and the number on the bottom goes outside of the division. Now, I'm not going to worry about the negative because I know my answer is going to be negative. So we'll just put the negative on that. What we need to do now is do the division. Well, you're having flashbacks to like 4th grade. Remember you put the decimal point after the 7 and then just add some zeros on there? And then the decimal point comes straight up. 8 does not go into 7, but it does go into 70. So 8 goes into 70 8 times. So there's our 64. Doesn't it feel good to have a pencil to do a math finally after all this time? All right, so 8 goes into 67. And into 45. So my answer is negative 0.875. You okay with that? Mm-hmm. Next, 13/5. So we're going to do the same exact thing. Top number goes inside. 13/5 means 13 divided by 5.
I'm going to have to get forks in my room.
I got 2.6. These are both examples of what we call terminating decimals. Terminating decimals. They stop. They terminate. Okay? 11/9. So 9 goes into 11 once. 9 goes into 20 twice. Uh-oh. What's going to happen here? Well, okay, so one option is we could have a remainder, but I'm supposed to be changing this into a decimal, so I don't want a remainder. I would have a remainder if I were okay with these fractions or whatever, but I need a decimal. What's it still repeating? Because see what's happened? When I did this subtraction, I got 20, but when I did this one, I also got 20, and if I keep going, I'm just going to keep getting 20. So how do I indicate that in my decimal? I put a little bar over the top. So the answer is 1.2 repeating. So what we have up here is an example, actually 2 examples of terminating decimals, terminating, they stop, and 1 example of a repeating decimal. Here we go. Let me try this mask. You might be able to hear me better with this one. Isn't this a nifty little thing? How about that? We'll see if this works better. You don't like it?
I mean, just personally, would that be okay if we came to school with them?
This is, they told us we could wear this if we were up at the board, but I can't wear this if I'm back with you because it's open down here. Mm-hmm. But they said if I'm at the board where any particles that are coming out of me are dropping to the ground and you're 6 feet away from me, it's okay. All right, next section, graph on a number line. Graph on a number line. Okay, so you know this is a number line. And I really don't know how, this Mrs. Hollis and Mrs. Ludington did this with you, but as far as I'm concerned, the only number you have to put on here is -2. Don't worry about putting 0 and hash mark. I don't need all that. The only number that matters in this problem is -2. And now I have to shade. So where am I going to shade? Which way, left or right? Right. Because this says x is bigger than -2. Now, is there anything wrong with my answer? Anything? That should be a closed circle. And how do we know that circle is closed?
Greater than or
equal to. So that makes a difference, and it's going to make a difference in a lot of different kinds of problems, whether that has an or equal to or not. So this one has an or equal to, so we color it in. Now, what does the next one look like? The next one has 2 numbers in it. So we're going to have 2 numbers. We're going to have a 5 and a 6. And the 5 dot, open or closed on the 5? Open. How about the 6? Closed. And then what about shading? In between. Very nicely done. Because the problem says that x is between 5 and 6. It's bigger than 5 and less than 6. Beautiful. Uh-oh. Tell me if you guys talked about this last year. What does this notation mean? Does anybody know what I'm talking about when I write that right there? Well, nope, that's a negative infinity. That's a negative infinity. So on your number line, where is negative infinity on the number line? That way, right? Okay. So anybody have an idea how I'm going to approach this? Well, I'm putting it on a number line, so I know I'm going to have a dot at 5. Now this problem is written in what we call interval notation. And those of you that are going to go on and take calculus, you have to get familiar with interval notation because that's all they use. It's very simple. The parentheses simply indicate that you're going to have open dots. Notice that in the next problem, there's a bracket. The bracket indicates a closed dot. So what this says is we have an open dot at 5, and then we're going all the way to negative infinity. So a picture of this interval looks like this. 5 is on the right. 5 is the rightmost point. And negative infinity is the leftmost. Now, we never put negative infinity on the number line. We never put a dot there because it just keeps going, right? You can't really locate it. So this just means that it keeps going forever and ever to the left. So the next one, now remember, parentheses, when we're writing in an interval, parentheses mean open and brackets mean closed. So could you sketch this interval? Two numbers on the number line. You're going to have a -2 and a 3. Remember, we never put infinities on the number line. Infinities just indicate we're going forever in that direction. But when we have 2 numbers, we have to locate them on the number line. Now, what does this bracket mean? Closed. That's a closed interval. So that's like the or equal to. So that colors that in. And then the 3, because it's parenthesis, it stays open. Now, where do you think I shade that? I've got this set of numbers that go from -2 to 3. So don't I shade in between? Sure. So this means exactly the same as this. This is the way you wrote it before. All the numbers between -2 and 3, including -2. This is the way we're going to write it now that we're big kids, you know, getting ready to go to calculus. We're going to write everything as an interval, but it means exactly the same thing. You just need to remember that bracket means closed, parentheses means open. All right, so what about this one? Take a minute and try this one on your own. I'll be quiet for a second. See if you can sketch that. Okay. Anybody want to tell me what you got?
For the closed circle on 7.
So here's 7. She put a closed dot there. Perfect, because it's bracketed.
And then a line to the right.
Shaded all the way to the right because it says go all the way to positive infinity. So that would be the same as this, right? One more. -3 to 3. Notice that they're both parentheses. That doesn't mean, that's not like an ordered pair. That's an interval. We're putting it on the number line. What about the dots at -3 and 3? Open. And since there's two numbers, I'm going in between them. It's not like this one where I had an infinity, right? Passing period, I tried to get out of it. All right, well that seems easy enough. Look at the next section now. Now, you are writing as an inequality. So what we mean by that, what I mean by that is write it this way, with an X and less than symbols and stuff, okay? So what do you think that's going to look like? You're going to have an X, and it's going to be between 5 and 7. Would you agree? If you were shading that, you'd shade between 5 and 7. And when you write a compound inequality like this, you always write the numbers in this order, little big, always little big. And the symbols are always less thans, always. Don't ever put a greater than in a compound inequality like that. They're always less thans. But because that's a bracket, this one will have to be an or equal to. Is that okay with everybody? I can tell you are so excited to be back in school. Okay, so now we have this one, and we're going to write it as an interval. Or excuse me, as an inequality. It is an interval. Writing is an inequality. Now, we don't have two numbers, so it's not going to look like this. What's this one going to look like? Wait, that needs to be a negative. That's a typo on my part. That has to be a negative. That's a mistake on my part. I need to fix that. Okay? Geez, first day of school and I've already made a mistake. Dang. Okay, what's that going to look like in terms of an inequality? X is less than or equal to 3. Why is it less than? Because this says 3 is the biggest number. This is the big number, this is the little number. So 3 is the biggest number, so everything has to be less than or equal to 3. How about this one? What's this going to be? An inequality. It's a picture. inequality, remember, is something that looks like this or this. These are inequalities. They have their less than symbol in them. What does it look like? Ellie?
6 is less than, or less than and equal to x, less than or equal to.
You even said it perfectly, that's right. 6 is less than or equal to x, less than or equal to 9. Perfect. Everybody okay with that? I hope you're thinking, man, Precal's easy. Because it is. One step at a time. You're going to do great. Now, we're going to write this as an interval. So an interval is something like this. These are intervals with the brackets and the parentheses. So what do you think this one's going to look like? Aiden. Pull your mask up. And then look this way. Okay? Please. What's that going to look like in terms of an interval? We're going to have 6 and an infinity. And they have to go that order. Because if x is bigger than 6, think about what that looks like on the number line. This is the small number, and the small number comes first, and it goes to infinity, so that number comes second. This one on the 6 will be a parentheses, because it's not an or equal to, right? I don't think I told you, infinities are always parentheses. Infinities are always parentheses. Anybody want to take a wild guess why? You can't be there. You can't get there. You can't put a dot at infinity because it's just, you can't get there. So it's always open. Always an open dot on the infinity. This one is open, a parenthesis, because there's no or equal to on the problem.
So like when you're just writing something else like x greater than 6, like when you only have like one number and like 2, it doesn't matter what sign you use, like greater than or less than.
Oh, yes, you're right. It depends which way you're going. That's exactly right. So if you've got 2 numbers, Parker, I see what you're saying.
Yeah.
If you're between 2 numbers, it's always less than. If you have just one number, it depends which way the arrow is pointing. Yes, great point, great point. Okay, what's the next one look like as an interval? So 5 is less than x is less than or equal to 10. What's that going to look like in terms of interval notation? Remember, interval notation is the parenthesis and the bracket. Okay, so what's it going to look like? Okay, I'm going to have to call on someone. We don't have volunteers. Danica?
Parentheses, 5, 10, bracket.
Beautiful. That's exactly right. Beautiful. And one more. X is less than or equal to negative 7. Now, you got to have 2 numbers, kids. But since there's only one number in the problem, you know the other one's going to be an infinity, right? Now, is it going to be the infinity first and then the 7, negative 7, or is it going to be the negative 7 first and then the infinity? If you are at all confused, yes, Kunkel.
Parentheses, negative infinity, negative 7 brackets.
Perfect. And if you're perfect. And if any of you are confused about that, think about what this looks like graphically. Because this would be negative 7 and then shaded that way, right? So when you write your interval, it's always little number, big number. It's left, right. So this has to be negative infinity, negative 7. And something's on the board that won't write, but that's a bracket. Awesome, awesome work. Let's do a couple more, and then let's just stop. I know you're thinking, dang, why did I have to get math for the long period today? Well, remember, when we crank through all this, you'll be reviewing when everybody else is catching up, so you'll get extra review at the end, and it's great. All right, number 5 says rewrite using the distributive property. Okay? So Jalen, you remember what the distributive property is? It's been a long time probably since you talked about it. Remember? Okay, what's that gonna look like? Exactly. Remember the distributive back when you were little kids, you probably went like this. That's what the distributive property does. Now, did you know though that the distributive property works the other way? In other words, in this example, we're going to undistribute. In other words, we're going to factor. Factoring is the distributive property. So take a look at these two terms. And Lily, what can I take out of those? What do they have in common that I can pull out? A 3, an X, and a Y, she says. I think she's right, do you? And if we take out a 3 and an X and a Y, what will we have left here? If we pull out a 3, an X, and a Y. X, and then our minus sign. Now we're going to take a 3x and a y out of that. And what will that leave us with? 2y squared. Remember, when we distribute it back, if we take this times this, we need to get this, right? So that has to be a 2. It can't be a 3, because 3 times 3 would give you a 9. That has to be a 2y squared. Very nicely done. The distributive property works both directions. Okay, now everybody's least favorite thing in the whole wide world, properties. So take a minute, and what have I got there? I don't know, quite a few examples, 8 examples. Take a look at them and see if there's any that you can do on your own. So if you think you know what property is, write it down over to the side, and then we'll run through all these. And then, what?
I remember, like, I just don't remember the names.
You don't remember the names of them? Okay, well, it's a good thing we're reviewing them then, because you got to remember the names of them. Okay, does anybody know any of them? Anybody have a thought on any of them? Yes, Tuttle.
The first one is identity.
Multiplicative identity, that's exactly right. Now, Mr. Tuttle, I am going to ask you to stipulate, it is an identity, but there are 2. There's multiplication and addition, so I want you to indicate it. So you can abbreviate, but this is the identity for multiplication. The multiplicative identity says that a number times 1 is itself. So yes, very good. Anybody know any others? Jim? F is, you're close. There is something called the reflexive property. But the reflexive property would say AB equals AB. That is reflexive. The reflexive property is when the 2 things are exactly the same. There's no difference in them. So that is not the reflexive property, but I'm glad you said that because it's close. This would be the reflexive property. Both sides are absolutely identical. That's reflexive. Are there any of those in there? No. Okay, all right. Anybody know any of the others? Parker? D is the additive identity. That's exactly right. The additive identity. We know that if we add 0, we get the same number back again. Very good. So we have an identity for multiply and we have an identity for add. Perfect. Anybody know another one? Oh my. We don't know any of the others? about the right side and the left side.
The order, the letters.
Order, keyword, order, the order changed. When order changes, it's commutative. And it's the commutative for multiplication. Because you can change the order in addition also. But that is the key, order. The order changed. That means it's commutative. So, Jalen, let's go back to problem F. What happened in problem F? Order change, so that's another commutative. And that is also multiplication, the commutative property of multiplication. Notice, by the way, there's no N in that word. It's not commutative, it's commutative. No points off for mispronunciation, though. But try to say it the right way. All right, let's look at C. What's different about the two sides in problem C? The parentheses. The grouping is different. The order's the same. It's X, Y, Z, X, Y, Z. But the parentheses are different. What property is that? Associative. So C is the associative property. And what operation is that in C? Multiply. So that's the associative property of multiplication. Beautiful, beautiful, beautiful. What about H? What's happening in H? It's also associative, but this time it is for addition. Now that leaves E and G. And in E and G, they're different, but the same thing is happening. When you multiply 3 times a third, they cancel each other out. You happen to remember that what we call the properties that cancel each other out? They're not the identities, they are the inverses. They're the inverses. So letter E is the multiplicative inverse, and letter G is the additive inverse. When they cancel each other out, 7 plus -7, gone. That's inverses. That's inverses. Yeah, I was just thinking maybe I'll prepare a sheet to put in Schoology for you to practice if you feel like you need a little more practice with that. I'll make it optional, and maybe I'll work on that. Hopefully I'll remember to do that for you. Okay, I think that's enough for today. So I'll make a little note here that period is and I think you can count on us finishing P on Monday. Looks like we don't have that much more to go. And I don't know where all these people are going. You're going nowhere. Yeah, the period isn't over.
Is it over at 1 though?
According to this, it's over at 1:10.
But then E starts at 1:10.
Oh, well maybe,
So I
is
think
it
it
over at
starts
1? Oh my, okay, well if it's over at 1, folks, I need to, I'm gonna go ahead, guys, oh shoot, I gotta put my other mask on. Guys, listen. Go ahead and get your stuff and leave. Normally, you have to stay clean, but I'm past due. So go ahead and I'll spray the desk and clean. I will see you on Monday. Be safe and smart. Make good choices over the weekend. This is the outdoor. Turn left. Bye. Out and left.
I haven't seen Dimitri
Put your
in
phone
like weeks.
away. Out and left.
Thank you.
Bye, you're welcome. Thank you for being here.
37.
Let's turn that